Welcome to this explainer. Okay, let's just dive right in. Have you ever actually stopped to wonder how typing a few simple lines of text on a screen can make a computer do exactly what you want? It feels a bit like magic, right? Well, today we're exploring exactly how Python code instructs computers. We're going to see how our human intent is translated directly into machine action. It is a really fascinating journey from the ideas in our heads straight down to the processing core of a machine.
So, think about this for a second. How do you give a map to a machine with literally no brain and then use it to solve the biggest problems in the world? It sounds like a total riddle. But the reality is, once you grasp the basics of programming, you can write code to create massive video games, build complex robots, and, yes, legitimately help solve those massive global problems. But to do any of that, we first have to bridge that massive communication gap between human beings and computer hardware. You can kind of think of coding as writing a secret message with special rules and symbols that only the computer understands. Because, let's face it, computers simply do not speak English. Programmers have to use specific, highly structured languages to give instructions, kind of like how you use everyday words to talk to your friends. It's really like writing a detailed story, but instead of words, you're using code to tell the computer exactly what its next move is. Let's start with Section 1, the language of computers.
Imagine a little girl who wants to reach her toys in a box across the room, but she has no idea how to get there. You'd have to give her a very literal step-by-step map of instructions. Go forward, turn left, turn right. Well, machines need that exact same level of literal step-by-step direction. Coding is fundamentally all about thinking step by step and then feeding those highly specific sequential instructions into a computer using a language it actually gets.
Moving right along to Section 2, compiled versus interpreted code. Generally speaking, there are two main ways programming languages process the instructions we give them. They are either compiled or they're interpreted. Compiled languages take your entire massive block of code and convert the whole thing into a machine-readable format before it can even be executed. On the flip side, interpreted languages, and this is where Python comes in, work very differently. They run the code directly, straight down, line by line. To give you a bit more context, with a compiled approach, languages like C++ or Java require a special program to translate absolutely everything up front. This heavy processing step spits out an executable file. You've almost certainly seen .exe files on your computer. And while that file can be stored and ran a million times instantly, there's a big catch. Every single time you make even a tiny change to your source code, you have to completely recompile the whole thing. As you can guess, this can make the development process noticeably slower. Now, contrast that with the interpretation process used by Python. If you look at the visual flow, notice how it loops. It goes one single line at a time. Python completely skips that heavy upfront compilation step. And the massive advantage here is the sheer speed of development. Because it's interpreted, you can make changes on the fly and just rerun your code instantly. If you have any bugs or errors, they pop up the exact second that specific line is hit. It is an absolute game changer for beginners because it gives you that immediate real-time feedback loop. Which brings us to Section 3, talking to Python interactively. Because Python interprets everything line by line, we can actually sit down and have a direct, real-time conversation with the computer. The way this interactive mode functions is called the REPL mode, REPL, and that acronym perfectly maps out this conversation. Step 1, the computer reads your input, your specific line of code. Step 2, it evaluates that code. Step 3, it prints out the results. And Step 4, it loops right back around to wait for your very next command. Read, evaluate, print, loop. To make this super concrete, this REPL mode actually lives right inside the Mu editor software, which is a really popular tool for writing Python. You literally just click that REPL button right up in the top menu. Instantly, Python shoots you a welcome message and just waits for your instructions. You type a line of code, press enter, and bam, the computer evaluates and prints the result right there on the spot. All right, Section 4, step-by-step execution. But what if you have a whole list of instructions? We're now transitioning from that quick interactive mode to how Python reads and executes full multi-line scripts behind the scenes. So here we have a short Python script over on the left, a representation of the computer's memory right in the middle, and our final console output on the right. When we run this script, Python doesn't just glance at the whole page and guess what we want. Actually, try running it in your head first. Starting right at the top, Python looks at the code, score equals 10 times 2, evaluates it, stores that in memory, and then moves exactly one line down. So here are the exact linear steps the Python interpreter takes. It reads the very first line. It calculates the mathematical value. It stores that result away in memory. Then, and only then, it moves down to the next line. Finally, when it hits a print command further down in the script, it pushes that final output out to the console. It is a perfectly logical, literal, and highly sequential process.
And that leads us perfectly into Section 5, storing data in memory. Now, you might be wondering, if Python is currently reading, say, line 5, how on earth does it remember information it calculated all the way back on line 1? Well, it does this using variables. I want you to think of a variable as a neatly labeled box inside your computer's memory, where you can stash a value to retrieve it later on. A computer's memory can hold billions of these tiny bits of data, so when Python needs that data again, it just searches for the box with that specific label. As you can see, the variable we named age is pointing directly to the assigned value of 10. From that moment on, whenever the Python interpreter sees the word age anywhere in your script, it bypasses everything else, goes directly to that labeled box in memory, and pulls out the number 10. The best part? You can use this variable as many times and in as many places in your code as you want, and Python is always going to know exactly where to find it. So, look at that. We've basically decoded this secret message. We now understand that Python interprets our instructions line by line, evaluates them, stores the data in labeled boxes we call variables, and spits out the results. Now that you actually know how to speak the computer's language, the ultimate question remains: what are you going to instruct it to do? The power is entirely in your hands. Thank you so much for joining me on this explainer. I really hope this sparked your curiosity to jump in and start coding today.